In this lesson, we are going to graph square root and cubed root functions. And if you take a look, I have the basic square root function and the cube root function, where h is the horizontal shift, k is the vertical shift, and then a, our leading coefficient, is going to tell us whether the graph is reflected or whether it is stretched. Let's take a look at the basic functions we have for our parent functions for square root and for cube root. So if we start with our basic square root function, and we'll put a couple of our points in, and we'll take a look at that. So let's pick some values for x. We're going to start with 0, 1, and 4, so that we are able to substitute those in for x and to take the square root. The square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2, because we're going to limit our domain with our square root function to be real numbers. So then we want our x value to be greater than or equal to 0. Because if we had a number that was negative, that would get us into our imaginary numbers. We also then, our range, which is our y value, because we're limiting our x value to positive numbers including 0. That would also mean that our range is going to be greater than or equal to 0. And if we were to make a quick sketch of this basic parent square root function, and we started with 0, 0, and then we had 1, 1, and then we had 2, 3, 4, 1, 4, 2, this is the shape of our basic parent function for our square root. Now if we take a look at the cube root function, and we want to build the table for that, we could do, because the cube root can have negative values, I'm going to start with negative 8 for the cube root, then I'm going to have negative 1, 0, positive 1, and positive 8. So the cube root of negative 8 would be negative 2. The cube root of negative 1 would be negative 1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is positive 2. So in this case, our domain with a cube root function would be any real number, because we can use positive and negative values. So our range as well will be all real numbers. And if we take a look at a quick sketch of our cubic parent function, and if we estimate, we'd have negative 8, negative 2, negative 1, negative 1, 0, 0, positive 1, positive 1, and over to 8, positive 2. Our basic cube root function as our parent function looks something like that. So let's take a look at an example, and it says to describe how to obtain the graph of y equals the cube root of x minus 2 plus 1 from the graph of y equals the cube root of x, which is our parent function. So the first thing that we want to take a look at is our basic cube root function, a, and then we have the cube root of x minus h plus k. The h and the k are going to give us our shift. So it says that we're going to shift, h is going to shift 2 units horizontally, and k is going to shift 1 unit vertically for our whole function. Now our leading coefficient happens to be 1 in this case. So if we make our table for our basic parent function of our cube root, and then we have negative 8, negative 1, 0, positive 1, and 8. If you recall then, the cube root of each of these, we have negative 2, negative 1, 0, 1, and 2. Because our leading coefficient is 1, that means our parent function values are not going to change. What is going to change is our shift to 1. Now the best place to look for that is where our 0, 0 is, and that is going to be where our 2, 1 is located. So if you'd go over 2 units and up 1 unit, that's what's going to happen. And I like to find that spot because then really what I could do from that spot is just do exactly what these ordered pairs tell me to do. It's like when we were doing our graphs of our parabolas and we use this new point as our new vertex and then we simply just graphed from there. I like to use that 0, 0 as my shift, my 2, 1, and then graph my points from there. So for example, from my new position here, I will go to the left 8, 1, 2, 3, 4, 5, 6, 7, 8, and down 2. And then go to the left 1 and down 1. And then I will go to the right 1 and up 1. And then I will go from that particular point to 1, which has been my original shift. I can go to the right 8 and up 2. And you'll notice what's happened is with all of our points from our parent function, they have been shifted to the right 2 and up 1. I just think it's easier to begin at this point and shift the 0, 0 to the point 2, 1, and then I'm able to count my other points from there. Again, with this cubic function, our domain will be all real numbers, and our range will be all real numbers. Let's take a look at another cubic function. So again, the first thing that I would like to do is to take a look at my h and my k values. So my h says that I'm going to shift my graph horizontally 3 units to the right, and I'm going to shift my graph 2 units up. So if we start with our basic table of our parent function, again for our cubic, -8, -1, 0, 1, and 8. And again, the reason we're picking those values is because they're easy to take the cube root of. So when we take the cube root of each of those, we have -2, -1, 0, 1, and 2. But now what we're going to do, because we do have a leading coefficient other than 1, we want to make this next column that allows us to shift, which is a vertical stretch, or our stretch is our leading coefficient, and also it might reflect our graph. So we're simply going to multiply our y column by -2. And then when we graph, we're not going to use this center column right here because we have transformed that with our new leading coefficient. So what we're going to start with, again, I told you that I prefer, instead of shifting all the points, if you can find the 0, 0 and do the horizontal and vertical shifts, which would be -3, +2, then from that point we can do each of our new points. So the first one would be -8, 4. So we're going to go to the left 8 units, 3, 4, and then 4 up, 1, 2, 3, 4. And then we're going to go -1, +2, and then we're going to go from, again, that point, we're going to go to the 1 to the right and 2 down. And then again from that point right here, we're going to go 8 to the right, which goes 1 off of our graph, and then 1, 2, 3, 4 down. So what's happened to this graph, it is stretched it, and then it's also reflected it because the leading coefficient is negative. So then we can draw in our cubic function. And the domain for this cubic function, again, because it's a cubic function, will be all real numbers, as well as the range being all real numbers. Okay, So one more time, what we're looking for is the h and the k to determine our horizontal shift and our vertical shift. Then we write the table with our parent function, and then our third column, if we need it, we will multiply our leading coefficient to find out our transformation if there is a reflection and it's negative, which is flipping our graph over, and then also we're determining our stretch. So let's take a look at a square root function this time. So when we're doing this, we want to find our h and our k. Now remember, with our h and our k, our basic square root function will be y equals a, the square root of x minus h plus k. And that h has a minus, so since we have changed that to a plus, that means our h value is going to be a -3. And our k value is going to equal 5. So in this square root function, we are going to move our whole function 3 units to the left and 5 units up. Now what we're going to do is to create our table with our basic square root parent function, and we did that with 0, 1, and 4 using numbers that are easy to take the square root of. And so with our basic function, if we want this, which is actually the square root of x, if we want to take the square root, that would be 0, 1, and 2. Remembering that we're going to use the domain of being greater than or equal to 0 and the range being greater than or equal to 0 to use the real numbers. Well, what we need to do now, since our a, our leading coefficient, is not 1, we need to add that third column. So we want to take that -2 times our y column. So that's going to be 0, -2, -4. What happens then is, because it is changed and there is a negative, that is going to be reflected, and it's also going to do our stretch transformation. So taking a look at our 0, 0 again, if we shift that according to our h and our k, we're going to move that from 0, 0 to -3, +5, and that's going to be the beginning of our square root function. Then what we can do is simply to use these two coordinates using our new beginning point at -3, +5. So from this point, we're going to move 1 to the right and 2 down. And again, back to our original point, we're going to go 4 to the right and 4 down. And then we'll draw that in. And you can see what has happened is that it has stretched and also it has reflected. Our original square root function went from 0, 0 and up in this direction. So now we want to list our domain and we want to list our range. In taking a look at this function, we find for our x values, we're beginning at -3 and going to the right. So x has to be greater than or equal to -3. And notice that that's actually our h value where we begin. Then for our y, we are starting at +5 and we're going down. So y is going to be less than or equal to +5. And notice that number value is actually our k value. Let's do another example of square root function. So first thing we want to determine is our vertical and horizontal shifts. So we're looking at our h and k. Again, the h value originally is a negative, so because it has switched to a +4, we know that our h, our horizontal shift, is -4, and our k, our vertical shift, is -1. So let's put our basic square root function table of 0, 1, and 4, and our square root at being 0, 1, and 2. This time, however, our leading coefficient is 2, so we're going to multiply our y column times 2 to determine our new values. So what we're going to do then is to use that to graph our new function. So we start with our shift from our 0, 0. We're going to go to the left 4 and down 1, and that's going to be our starting point. Then from that point, we're going to use these two coordinates to determine our next points. So from this beginning point, we're going to go to the right 1 and up 2 units. And back to that original point, we're going to go 4 units to the right and 4 units up. And then we'll draw that new function. So taking a look at the domain of this square root function, we know that x needs to be greater than or equal to -4, and the range for this particular square root function, we know that y needs to be greater than or equal to -1. And again, we can find those values with our h and k and then determine if it should be greater or less than. So when we're graphing square root functions and cube root functions, make sure you look at the original function to find the h and the k, which is going to determine our horizontal and our vertical shifts, which will translate the graph. Then use the parent function to graph, being sure to look at the leading coefficient to determine the stretch and or the reflection of the graph. And then determine the domain and the range.